Okay, this is Physics 112, Lecture 7. And today I'm going to do example 18.4. In this example, what we want is we want to find the electric field at the origin of the coordinate system, where two charges are placed, one on the x-axis and one on the y-axis. Both of them are positive charges, and this is 1, 2, 3, 4. This is 4 centimeters, and this is 2 centimeters. This is Q1. This is Q2. This is 4 centimeters. This is 2 centimeters. Okay, and both of them are positive charges. Q1 is 5 times 10 to the power minus 9 coulomb, because it was given as 5 nanocoulomb. But we have to use the units coulomb so that the electric field will come out with newtons per coulomb with the correct unit, right? So you cannot use nanocoulomb. You have to convert it into coulomb. That is, nano is 10 to the power minus 9. Okay, Q2 is also in nanocoulombs. Q2 is 10 nanocoulombs, or 10 to the minus 9 coulombs. All right. Now, distance R1 is 2 centimeters, so R1 is 2 centimeters. But we cannot use centimeters, we are going to use meters. So 2 centimeter, in 1 meter there are 100 centimeters, so you have to multiply by 2 times 10 to the power minus 2 meters. Okay, similarly R2 is 4 centimeters, so that's 4 times 10 to the power minus 2 meters. Alright, so now both of them are positive charges, and as we have discussed before, electric field lines from a positive charge will be pointing away from the charge. So this is the charge, then the electric field at this point will be pointing in this direction. Okay, so that's, let's call it E2 vector, because in this direction, and let's say it's about this much. And Q1 is also positive, so at this point the electric field will be pointing in the positive y direction, that is away from the charge. So it'll be just, let's say, about this much, E1. So then the resultant vector will be, it will go according to the parallelogram law. That is, you draw a parallelogram and then you connect the diagonal. So let me draw this a little bit here. So my lines are always crooked. So then it'll go from here, origin to there, right? So that will be your resultant vector E. What we want is the magnitude of this vector E and the angle that it makes with the x-axis. Okay, actually it doesn't matter which one you want this or this, right? As long as you get one angle, that's fine, but usually we give this one. So magnitude wise, this height will be magnitude of E1, and this little projection will be magnitude of E2. So the angle can be found by using E1 and E2, right? So E1 is the opposite, E2 is adjacent, right? So we are going to do that also. So first, let me use the formula for electric field, and then let's calculate how much it is. All right. So let me see if you can see the picture. So the formula for electric field is E magnitude is equal to K Q by R squared. So for E1, obviously E1 magnitude will be equal to K Q1 by R1 squared, right? And K is 8.99 times 10 to the power 9 Newton meter squared per Coulomb squared. And Q is, now we know Q1 is 5 times 10 to the power minus 9 Coulomb, and the distance R1 squared, R1 squared is 2 times 10 to the power minus 2 meter squared. So you see meter squared and meter squared, they will cancel out, and Coulomb square and Coulomb, they will cancel one of the Coulomb, so it will be, answer will be in the units of newtons per Coulomb, right? And I can just plug it into the calculator, all right? And I can use the result from the book, or I can plug it into the calculator. So I'll do it two ways. Let me use the book answer. The E1 is 1.124 times 10 to the power 5 Newton per Coulomb, 1.124. So that's 1.124 newtons per Coulomb. Oh, sorry. I'm sorry. Times 10 to the power 5 newtons per Coulomb. Okay. Now I'm going to do it in another way. All right. Let's see if we get reasonable result. And the thing is, see, sometimes you guys trust calculator too much. So I'm going to show you how to do that without using the calculator. All right. So this is without calculator. Not that you have to do without a calculator. I'm just telling you so that you will know what you get from your calculator is correct. All right. So let's look at this. 8.99 is approximately, so E1, my approximate answer would be 8.99 is just about 9. 10 to the power 9. So I will deal with these 10 to the powers later. Let's take this number 5. So I'll multiply by 5. 2 squared is 4. So let me divide it by 4. Now in the numerator I have 10 to the power 9. I can do this in my head. You can do that in your head, but you can do it later. Right now, 10 to the power negative 2 squared is 10 to the power negative 4. So you see, the units we checked that's newtons per Coulomb. So 10 to the power positive 9 and 10 to the power negative 9, when you multiply, you add the exponent. So positive 9, negative 9, they cancel. 10 to the power 0 is 1. Okay? And it's approximately equal to 9 times 5 by 4. So that's 45 by 4 times 10 to the, this and this cancel out, 10 to the power, if you take it in the numerator, it becomes negative, exponent becomes positive, Newton per Coulomb, right? So, what is that? Well, so you can divide 45 by 4, so you can divide, 4 goes into 1 times, so another 1, so 1 left over. So if you put a decimal, then you divide 10 by 4, so that's 2, right? And then so then you have 4 times 2 is 8, so you have 2 left, so then you will have 5. Right? That's approximately that. times 10 to the power 4 newtons per coulomb. So you can move the decimal place like the book. You'll get 1.125 times 10 to the power 5 newtons per coulomb, right? So you look at that 1.124 and 1.125. So that's not too much, right? Okay, so 1 part in 1,000. So you see, you can do that mental calculation. Even if you stop at 11, then you see, your answer is approximately correct, so that you don't have to worry whether this answer is correct or not. So the more you have these numbers, then the more you have to worry, because then there's better chance that you will type in some wrong numbers in your calculator. All right, so that's an example of how you do this thing. Now let's do example E2. So this is just extra for you guys, right? So let's do E2. And E2 magnitude is again K Q2 by R2 squared. So let me substitute. K is 8.99 times 10 to the power 9 Newton meter per coulomb, Newton meter square per coulomb squared. And Q2 is what? Q2 is 10 nanocoulombs. 10 times 10 to the negative 9 coulombs divided by R square. R square is R2 is 4. So that's 4 times 10 to the power minus 2 meters squared, right? Okay, so meter square cancel out, coulomb, so Newton per coulomb, that will be answer. Then you can plug it in your calculator, and the answer you will get, I'm just copying it down, is 5.5619 times 10 to the power 5. So 0.5619 times 10 to the power 5 newtons per coulomb. Okay? Now we have the magnitude of E1 and E2. So all we have to do is find the resultant vector. So how do we do that? So let's find the resultant vector. So that will be page 9, I guess. Physics 112. Now, continuation of example 18.4. So now the resultant E magnitude is equal to square root of E1 squared plus E2 squared, right? So our answers were 1.124. So let me show you again. That's 1.124 times 10 to the power 5 squared plus 0.5619, so 0.5619 times 10 to the power 5 squared, and the answer will be in Newton per coulomb, right? So now you see, you don't have to plug in 10 to the power 5 into your calculator, because this is 10 to the power 5 squared, this is 10 to the power 5 squared. Let me write it out in longhand. 1.124 squared plus 0.5619 squared. And then I can pull out 10 to the power 5 squared as a common factor, right? So Now I can pull this out of the square root. So this is 10 to the power 5 squared. If you take the square root, it will be 10 to the power 5. So then I don't have to put this in your calculator. So my answer would be 1.124 squared plus 0.5619 squared times 10 to the power 5 newtons per coulomb. Okay, so then at this point you can use your calculator, and the answer is 1.26 times, so the answer is 1.26 times 10 to the power 5 newtons per coulomb. Okay, all right. Now what about the angle? So this is the magnitude of this vector. Let me put back the first page. So see, in this picture, this is the resultant E, and the magnitude is just what we have found, right? So the magnitude is that 1.26 times 10 to the power 5 newtons per coulomb. Now we want to find this angle. So the angle is, the tangent of this angle is opposite side, which is E1, divided by adjacent, which is E2, right? So then tangent theta is magnitude of E1 divided by magnitude of E2. Okay, so then theta is equal to tangent inverse E1 by E2. So magnitude of E1 is 1.124 times 10 to the power 5 newtons per coulomb, and magnitude of E2 is 0.5619 times 10 to the power 5 newtons per coulomb. They cancel out. And the answer is 63.4 degrees, right? So these 10 to the power 5 cancel out, so I just have to use this, and this is 63.4 degrees. So 63.4 degrees. Okay, so make sure you put your calculator in the degree mode. All right, okay, so I'll see you in next lecture.